All right, recording is rolling. It is Thursday, the 2nd of November. I got a mechanical advantage lab lined up for you guys, Pulleys Lab. So, reminder, textbook puzzles are due tomorrow. We've gone over all this in class, gave you guys some time yesterday to work on those too. And your guys' energy quiz that I gave you guys yesterday is due on Monday. The quiz before this one, which was like a circular motion and gravitational orbits, right? I haven't handed that back yet. There's still some students like 2 weeks later who haven't turned it in. So check focus, make sure that you're not one of those students who hasn't turned in the previous quiz. If you are and I don't get it by tomorrow, then I'm just gonna leave it as a 0 in the grade book so I can get everybody's quizzes back to your folders over the weekend. Yeah. So yeah, the previous quiz will be back in your folders by Monday, right? All right, let's get what we're doing today. This pulley system. So let me back up a little bit and look more broadly at simple machines. Simple machines, you can get some kind of mechanical advantage. You can amplify your strength, but remember, you can't amplify the amount of energy, like the number of joules. So here's all different types of simple machines. We're going to focus on this one today. You guys see some equipment on your desk, some ring stands and string and pulleys, all kind of fun stuff. Right. Here's some other types of simple machines. Okay. Like if you ever have a heavy box and you put it on wheels, so maybe I can't lift it, but I can push up an incline. The ideal mechanical advantage is, say, like the ratio of these distances, but your actual mechanical advantage is the ratio of, well, what's the weight compared to how much you have to push it up the incline. If it's like a 1 degree incline, you're getting a huge mechanical advantage. Okay? The catch is, of course, you have to push it a long distance to raise it a little bit. You can also get a mechanical advantage from like wheels. Here I got maybe there are two wheels fixed relative to each other. It's just the ideal mechanical advantage would be the ratio of the radial sizes. This actually, even though I'm calling it wheel, is kind of a version of a lever, isn't it? Right? This to take away the wheel aspect, and if you just look at the ratio of those distances from that center point, right? It's kind of like kind of like a lever from the pivot point. Is really kind of what that is, right? You just make it round and throw a bunch of string on it. You can put the long distance, right? Again, your actual mechanical advantage would be, well, what's the ratio of these forces, right? The weight compared to your input forces. Okay? But here's the one you guys are going to focus on today. Well, here's one of them, right? A 3-1 mechanical advantage for a pulley system. Okay? So you have some input force to lift a heavy weight, okay? And you need to pull some distance to lift that weight. Okay? Now, force times distance in equals force times distance out. At least that would be true for 100% efficient. Okay? Your ideal mechanical advantage just comes from the geometry. So here I'm seeing like 3 strings up for 1 string down for this movable pulley. Okay? Or you could say, how far did I have to pull on the spring scale side to lift it some distance on the opposite side? Okay? You guys got rulers on your desk. Okay? And what's your actual mechanical advantage? Well, it's the ratio of these forces, right? How much are you lifting compared to what input forces it take to do that, right? This should be pretty close to 3-1 for the setup, but it might be a little bit less because you might have some frictional losses. Maybe these strings aren't exactly vertical. There's a trigonometry aspect. Okay. So here's what I have you guys do today. You guys got some paper. Give me that paper into quadrants, put your name on it, and we're going to do 4 different mechanical advantage labs, 4 different pulley systems. If you don't have any paper, hey guys, I got a whole stack of paper right here, whole stack of paper. So if you don't have your own paper, there's some paper right there. Okay. I think I went through these yesterday. Got 1-1, 2-1, 3-1, and 4-1 mechanical advantage. At least that's the ideal mechanical advantage. Okay? You guys have all the things on your desk that you need to construct these, and also all the tools you need to measure. Okay? So you guys have ring stands. You guys got some kind of ceiling going on. You guys got string. You guys can tie these different pulleys to the ceiling. Right? Okay, string obviously for like this brown string here. Wind it around. You guys got some brown spring scales. You guys got some lab weights going on. I gave everybody has at least the 500 gram, or just say 5 Newton weight, and also the 10 Newton weight. Yeah, that's what I'm gonna have you guys do. Yeah, so once you guys got these divided into quadrants, right? So draw each picture and then make each one of these tables, right? So I want to say about this equipment, I want to talk about equipment. You guys got 2 different type pulleys. Right? Oh, actually, there's some quirky ones out there too, but here's the main ones that you guys care about, right? Like the single wheel and the double wheel. Right? Like this double wheel might be especially helpful for some of these bigger ones, right? Like this 4-1. instead, you could construct the 4-to-1 like this. Last class, there were different design 4-to-1s. Some uh, students made one that looks exactly like this one here. And some students said, well, hold a minute. I could, instead of having two singles stacked on top of each other right here for the movable pulley, I could instead just have a double pulley right here in place of these two, right? Which probably be a little bit cleaner design, right? So you could do that too. Yeah, so draw every single one, have a table for each one, and fill out each table. So what's input versus output force, what's input versus output distance, right? You guys can hold a ruler or a meter stick next to each one, see how far does it move. Calculate what is your ideal versus your actual mechanical advantage. Now, to help you guys out there, this poster is hanging in my room, so you can remember, oh yeah, okay, that's what ideal versus actual mechanical advantage are, right? These different ratios I'm looking at, right? They should be pretty close to each other. If you want to, you could do the extra steps saying, well, what's the efficiency of the system, right? But some of these are somewhere between 90 and 100% efficient. Okay? And finally, if you want a working model, I've had a 5-to-1 rigged up since the very first day of school that you guys walked in. I was giving a presentation about fire drill and all that stuff. Right? And I moved over to there to that lab table. You guys see on the lab table, there's a 5-to-1 rigged up. Right? A 5-to-1. Right? So if you want to get your hands on that, see what that feels like, get a close-up look, how I wanted to swing around for a 5-to-1, you have to. Okay. So when you guys finish these, just turn this page into the grade tray, and I will check that off and give you guys lab points. All right. So you guys got all class. I'll walk around, help you guys out, answer any questions you guys have.